Okay, this is the second half of lesson 8.1. So just to remind you, and make sure you have this in your notes if you were taking notes remotely yesterday. So interpreting a confidence interval. This is the script we use to interpret a confidence interval. So, to interpret a C percentage, usually it's like 95% confidence interval. You might say something like, we are 95% confident, or whatever C is, that the interval from blank to blank, the lower bound and upper bound, captures the true mean in context, whatever we're actually talking about for that particular problem. So today we're going to the next level. We're talking about interpreting a confidence level. So that's interpreting the 95% confidence level, or whatever level we're at. So this is how we say that. This is the script for this one. If we were to select many random samples from a population and construct a 95% confidence interval, or whatever it is, using each sample, about 95% of the intervals would capture the true parameter. Now, it's hard to picture what that's saying. Let's just talk about this one. So 2 weeks before a presidential election, a polling organization asked a random sample of voters, if the presidential election were held today, who would you vote for, candidate A or candidate B? Based on the polls, a 95% confidence interval for the population proportion who favor the candidate A is between 0.48 and 0.54. Interpret the confidence level. So if you go back to this, we say, okay, if we were to select many, many random samples of a population and construct a 95% confidence interval, using each sample, about 95% of the intervals would capture the true percentage or proportion of voters who would favor candidate A in this context. And so that's what they would say. This is a picture of that, so to speak. So if there were like, there's about 20 there, about 1 out of 20, the interval would not capture the true mean. Whatever that true mean is, that green line is like the true mean there. So 95% of the intervals would probably capture the true mean. It would be within the interval. But every once in a while, you get one where the mean is not in the interval, right? It does not capture the interval. So that red interval there is an example of what could happen because we're only 95% confident. We're not 100% confident here. Once you've calculated your particular confidence interval, it either includes it or it doesn't include the actual mean. So we don't really know, but we're 95% confident it does. Does not tell us the probability that a particular confidence interval captures the population parameter. Or both, and that's really true. You might have to do both. It's actually pretty common. So you need to understand the difference. I think that's the toughest thing about this particular lesson. The confidence interval, I like this, gives a set of plausible values. So the interval, if you're interpreting an interval, that's the set of plausible values for the parameter. Confidence level describes the capture rate, how often it actually captures the mean it's looking for. In general, we would like to estimate with a small margin of error, ideally, right? What makes a margin of error get smaller? So there are two things. One is when the confidence level decreases. This is not ideal. So if I were, say, 80% confident, which we don't say that often, usually it's 95%, but let's say it's 80%, then I'm guessing a little tighter window there, if that makes sense. So I'm not as confident. I'm going to capture the true mean, but also not as confident. So it's a smaller range though. If I guessed a really small interval, I might be like not very confident. Let's say a graph, I guess it's going to be exactly between 240 and 242. It might be like a 20% confidence that that's true. In other words, I'm not very confident that I really guessed correctly at all. So you don't want that confidence level to go too low, but if it goes lower, you will have a smaller margin of error. So if that's what you're looking for, you can do that. This is the preferable way to make a smaller margin of error. If the sample size increases, that's much better. And the formula there is 1 over the square root of n. So quadrupling, multiplying the n value by 4, cuts the margin of error in half. It's kind of an easy thing to do in your head. 1 over square root of 4 is 1/2, so it cuts it overall in half. So but that costs a lot more. So this can be costly, like money-wise. If you're doing a presidential poll, and normally they just do 3%. If you want it to be a margin of error smaller than that, you have to do a much bigger sample size there. So it may not be worth it. That's actually a good word of warning. It doesn't account for bias, so it just, says how confident we are of something happening. So normal, sampling, the empirical rule, 95% is within 2 standard deviations. So that's, typical. 3 standard deviations would be 99.7%. So this is a formula we'll get into later. I don't think we're really talking much about it this one, but you're introduced to it here, and we'll use this more when we figure out the critical value. But statistic plus or minus the critical value times the standard deviation is the general formula for a confidence interval. I think, again, we'll use that later especially, but it's a multiplier. Makes it wide enough to have the stated capture rate. Okay, part of a project about response bias. Ellery surveyed a random sample of 25 students from her school. One of the questions in the survey required students to state their GPA aloud. Based on the responses, Ellery said that she was 90% confident the interval from 0.4 to 0.72 captures the proportion of all students at her school with GPAs greater than 3.0. Explain what would happen to the length of the interval if the confidence level were to increase to 99% confident. So if I'm 99% confident instead of 95% or 90% confident, 90% confident instead of 99%, what's going to happen to that interval, right? So the confidence level. So it's going to be wider, right? Because to be more confident, we have to have a wider kind of net to catch that true mean in. Second question, how would the width of the 90% confidence interval based on the sample size of 100 compare to a 90% interval assuming the sample proportion remained the same? So I think they took a sample of 25. So they say if they actually changed it to 100, so they made a much bigger sample size. That should make us, what should happen to this? It would be about half as wide. It's 4 times as big. And so 1 over square root of 4 is 1/2. So it's about half as wide because we took a much better sample size. So the margin of error is going to get smaller. Describe one potential source of bias. I always study that is not accounted for. Well, I mean, just the way she asked it, right? The students are saying their grade point out loud. I don't know about that as a teacher. But I think there might be some students that might not tell the truth there. They might lie about their GPAs based on they're not proud of their GPA, potentially. Okay, so we're done with the lesson part, basically, but let's just go over a few problems, make sure you get it. So again, part of this is just understanding the difference between confidence interval interpreting and confidence level. So a counselor at a large high school, wants to estimate the mean amount of sleep that students got the previous night. She selects a random sample of 10 students and asks them to record the number of hours they slept last night. That should be interesting. Based on the sample, the 95% confidence interval for the population mean amount of sleep for all students is between 5.39 and 7.81 hours. Okay, so we think we are 95% confident that the interval from 5.39 to 7.81 contains the true mean of the population, in this case, the mean amount of sleep for this large high school for the students, and that's, what it is. What is the point estimate that was used to create this interval? So you might need to get your calculator out at this point. And you say maybe find the middle, 5.39 plus 7.81, add them up, divide by 2, so we get 6.6. So 6.6 is that point estimator. The margin of error would be the difference between 6.6 minus 5.39. So that difference would be 1.21. So that's the margin of error. So we're plus or minusing 1.21. So it's 6.6. Plus or minus 1.21. Yeah, margin of error is 1.21. It is recommended that high school students get 8 hours or more sleep, and that, of course. Based on this survey, students claim that on average, students in high school are not getting the recommended amount of sleep. Use a confidence interval to evaluate this claim. So this is a very common thing here. So does that interval, 5.39 to 7.81, contain that mean of 8? Is it within the interval? It's not. So I would say we are pretty confident that these students are not getting 8 hours of sleep on average, right? Because all plausible values, I like the way they said that, are less than 8 hours, 5.39 to 7.81, the interval gives convincing evidence that students in the high school did not get the recommended amount of sleep, and that's no surprise, right? Based on a random sample of 10 students, a counselor calculates that the 95% confidence interval for the population mean amount of sleep for students is that. Interpret the confidence level. So if we took many, many samples of size 10, we are, so about 95% of the intervals that we got from that would contain the true mean amount of sleep for the students. Boy, that's hard to say. If we take a random sample of 10 students and construct a 95% confidence interval using each sample, about 95% of the intervals would capture the true mean amount of sleep. So if we created a whole bunch of them, that's what would happen. Part of a project about response bias, Cody surveyed a random sample of 40 students from his school. Both of Cody's parents are dentists, so many of the survey questions had to do with brushing teeth. One of the questions required students to state aloud whether or not they brush their teeth twice a day. Based on the responses, Cody said he was 90% confident the true interval for 0.79 to 0.96 captures the true proportion of all students at school brush their teeth twice daily. Explain what happens to the length of the interval if the confidence level were to increase to 99%. So if you wanted to say he was 99% confident that some interval would do that, then the interval would have to be smaller, right? Because you'd take a better guess there. He's more confident, so the interval would be wider. It is weird, isn't it? So because increasing confidence level increases the margin of error. That's, of course, true when you think about it. What would happen to the length of a 90% confidence interval if the sample size were increased to 100 students? So it started with 40 students, increased to 100 students. So if we do that, the margin of error is definitely going to go down in that case. I think that is right, because increasing the sample size decreases the margin of error. Describe one potential source of bias. They're studying bias, evidently. And I think saying whether you brush your teeth twice out loud or not, some people are not going to tell the truth. Great. That's the lesson for today.